Hi everyone, so today we're going to continue solving rational equations and we're going to really work our way up to solve some more complicated equations. And I know I mentioned this last week as well, so I'm going to show you kind of the progression here. So we started last week with cross multiplication, so here were some examples that we did. And then yesterday you should have reviewed factoring. That's going to help us a lot today and throughout the rest of the week. So today we're going to focus again on equations that could be used with cross multiplication, except for we are not going to use cross multiplication. I'm going to show you another method for this. Now, the reason I say they could be used with cross multiplication is because they're going to have one rational expression on either side of the equal sign. But our goal is to solve some more complicated rational expressions or equations, kind of like here when you see 9 and 10. And again, they get more and more complicated as we go. But we're going to slowly work our way up to this. So I'm going to go back up here. So I pulled this worksheet from my Algebra 2 notes. So I'm going to kind of skip around here a little bit. For example, I know I'm not going to cover 5. But before we even get into any of the problems on the page, so what I'm going to show you today is another method instead of using cross multiplication. And it's very similar to cross multiplication, except for it will help us a lot more in the next few days. So for example, if I give you the problem 3 over 7 equals x over 7, could you tell me what x is equal to? So you might have already noticed, okay, well the denominators are the same, so then the numerators need to be the same. So that means that x equals 3. Likewise, what if I had x over 11 equals 4 over 11? Again, hopefully you're noticing, okay, if the denominators are both 11, then my numerators need to be the same, so x equals 4. Well, what if I made it slightly more complicated? Let's go x over x plus 1 equals 5 over x plus 1. Now, don't let this one trick you. Again, because my denominators are the same, my numerators must be equal, so x equals 5. Now, in all three of these examples, the reason that they were so easy is because our denominators were the same. So that's going to be our goal for today, is to make those denominators the same. And in order to do so, we're going to rely a lot on factoring. So for example, if you look at this problem labeled number 6 here, I have x minus 3 divided by 2x minus 8 equals 2 divided by x minus 4. Our first step is to factor the denominators. So on the left-hand side, I have 2x minus 8. So I can factor out a 2. Both of them are divisible by 2, so I'm left with x minus 4. And then I'm just going to cross this out so it doesn't confuse me. Well, notice here, both denominators have an x minus 4. But on the left-hand side, I also have this 2 that I'm missing on the right-hand side. So in order to take care of that, I'm going to multiply both numerator and denominator by 2. So when I multiply that across, I get x minus 3 over 2 times x minus 4 equals 2 times 2 is 4. And then I'm just going to leave the denominator factored. Well, notice now my denominators are the same. I have a 2 in both. I also have an x minus 4. So I can just focus, sorry about that. I can focus on those numerators. So if I say, okay, x minus 3 must equal 4, then I add 3 to both sides, and I get x equals 7. So we're going to obviously try a few more examples. But going back through our steps real quick, we factor the denominators. Then we multiply in order to make them the same. And then you focus on the numerators. That's kind of a very quick explanation there. Okay, so looking at number 7, first thing I do is factor the denominators. So over on the left-hand side, since I have x squared plus 4x, I see that they both have an x in common. So I'm going to factor out an x, and then I'm left with x plus 4. I'm just going to cross this off. On the right-hand side, I only have an x plus 4, so I cannot do anything there. So again, I notice, okay, well, both the left and the right have this x plus 4, but the left-hand side has this additional x that the right side does not. So I'm going to multiply both numerator and denominator by x. The minute my denominators are the same, I have that x in both, x plus 4, I can just focus on the numerators. So I get 3 equals 1x, or x equals 3. Okay, number 8 is slightly more complicated. So over on the left-hand side, I have x squared plus x minus 20. This is kind of like the problems that you were doing yesterday. So I need to set up my two sets of parentheses. I know that I have x and x. I need two numbers that multiply to negative 20 and add to x. So I'm going to use 4 and 5, positive 5, negative 4. Then I'm going to cross this off so it doesn't confuse me. Okay, so I need to make these denominators the same. I notice that both the left and the right-hand side have x minus 4, but the left-hand side has this additional x plus 5. So I need to add that to the right. So I multiply both numerator and denominator. Now that they are the same, I can focus on the numerators. So I'm going to rewrite this down below. So I have 4x minus 8 equals 2 times x plus 5. So I distribute the 2. And then solve for x. So I would subtract 2x from both sides and add 8. And then finally divide by 2. So my final answer is x equals 9. Okay, those are my examples for today. So I'd like you to try the practice Canvas quiz, and then tomorrow we'll add on a little bit more.